In today's session, we'll continue with the problems on beam topic. So in this way, a problem with us, the beam of span 12-meter shown in figure is hinged at A and on the rollers at B. Determine the reactions at A and B for the loading shown in figure. The diagram is given like this one. So here the hinge support with us. So at point B, sorry, at point A, the hinge support is given, and at point B, roller support is given. Okay. Now you have to do calculations for the reaction at point A and reaction at point B. So for that, first of all, draw the free body diagram. That can be drawn in this way. Free body diagram for given loading as. Now draw the diagram this way. First of all, just concentrate on the given diagram carefully. You have to draw the free body diagram. Now, whatever the support given, you need to convert that support into its reactions. What's about the here? Here the hinge support with us means the two reactions will come. One will come in horizontal direction, another one will come in vertical direction. Okay. So next the force is nothing but the point load. Just show that point load as it is at a distance of 4 meter with respect to this point. Okay. Here, so this 10 kilonewton as it is. So what's about next one? 15 kilonewton at a distance of 2 meter with respect to this one. The 2 meter actually distance with us. Simultaneously think over these forces given and the distances. Okay. So here we can just show here. Okay. So this distance with us 2 meter. Then just show the 4 meter because the distance this point A point, this point with us 4 meter, here the 2 meter with us. So this force with us in inclined direction. Now resolve this force into its components. Okay, resolve this force like this one. One component will come in horizontal direction, other component will come in vertical direction. What's about its magnitude? Here the 15 kilonewton with us. What's about the horizontal component of this one? 15 kilonewton. 15. So what's about this angle with us? 30 degree. What's about the horizontal component? 50, 15 cos of 30 degree. Okay. So what's about the vertical component? 15 sine of 30 degree. This way. So the resolution of these 2 points is over. Now it is not necessary to write the original component here. Okay. If you just show, just show that component and keep that component as it is. I'll just show that component in this way. So this is nothing, sorry, original force with us 15 kilonewton. Okay, with us 30. Now what's about the next one? So next force with us 20 kilonewton. For that also just show the two components. One will come in horizontal direction, whose magnitude with us here one component horizontal direction, other component in vertical direction. Here that the another actually component will not mix up with the actual shown here for the one component will horizontal vertical direction, component will come in this one. Sure that what are the distance earlier we have shown proportionate for this 4 meter and this 4 meter is approximately same for this. So what's about the magnitude for the same 20 kilonewton with us? So 20 kilonewton horizontal component for the same with us 20 cos of 45. What's about the vertical component? 20 sine of 45. At the same time, what's about this one? This is nothing but the roller support. In case of roller support, so one reaction this way. Okay, this reaction is nothing but the RB reaction. So this is the free body diagram of the given system. So this force also you can just show here. What the force Newton then 55 degree about your body diagram. Once the free body diagram is drawn by us, now this is the case of general force system. In case of general force system, by applying the conditions of equilibrium, how to solve this one? Okay, this will clear you in the coming step. Okay, so here apply the conditions of equilibrium. Mention here, applying conditions of equilibrium. Okay, what's about the conditions of equilibrium in case of general force system? We know summation of f of x equal to 0, then summation of f of y equals to 0. The moment about, if I just consider this point, moment about this a point equals to 0. Okay, now apply one by one equation and get the answer for your required unknowns. Okay, so here first of all just apply this one first equation. Now summation of all the forces along the horizontal direction equals to 0 equals to, just continue this equation. Now focus only on the horizontal forces. The first force is here whose magnitude HA running towards right direction. It is very important to consider this as here. So this one is positive, this one is negative. Mention the convention of this one or above this one. So HA running towards right direction. Consider this one as positive. What's about the next one? The component of this one. Component of this 15 kilonewton along the horizontal direction with 15 cos of 30 running in opposite direction of this. So the minus sign here. So 15 cos of 30. We get the cos of 30. So another compound is here. Compound of this 20 kilonewton in horizontal direction with us. Whose magnitude 20 cos of 45 with us. No more force available with us. Equate all these things with a 0 and just solve this one for HA. Take this HA towards one side and all the terms towards the other side. If I take this terms towards the other side, it becomes a positive. So solve this and get the value for HA. So solving, you can get the in just 5 can get 27.13, 27 25 kilonewton, okay, for the HA. Now move towards the next one. Now move towards the next condition. This summation of f of y equals to 0. Now summation of all the forces along the vertical direction equals to 0 equals to this assignment. One positive, this one. Now what's about the first force? So BA is the first force with us vertical in upward direction. So what's about this one? 10 kilonewton force with us in downward direction. So one more force with us here, 15 of 30 vertical in the downward direction. So what's about this one? Vertical in the downward direction, this force 20 sine of 45 vertical in the downward direction. So what's about this one? Vertical in the upward direction. So solve this one. A, get the information regarding the A plus RB equals to, take rest of term towards the another side. You can get the terms. What's about the value for the same? You can get the 10 plus 15 by sine of 30 plus 20 multiplied by sine of 5. Get 31.64 for this one. 31.64 plus equals to 6421 for this one. Now move towards the next equation. For that you have to take the, you have to apply this equation and about point A equals to 0. Just here taking point, taking all forces about this point A, taking about point A from all the four goes to. Just continue here. So here is the first point, or A point with us. Line of action of this force passes through this one. This force passes through this one. The moment of this one and this one becomes 0. So next one is here, 10 kilonewton. Tendency of this one turn about this point to turn about this point in clockwise direction. For that, to the minus sign. Okay. So 10 multiplied by distance with us 4. Next force here 15 cos of 30. Again see the line of action of this force passes through this one. So you have to neglect this force. Next one is here 15 sin of 30. The tendency of this one to turn about this point again in clockwise direction. 15 of 30 divided by what's about the distance with us. So 6 with us. Next one with us 20 sin of 45. And the tendency of this force to turn about this point in clockwise direction. 20 sin 5 the force by distance. So sorry, here with us. So 20 sin of 45 by how much distance? 4 plus 2 plus 4. So what's about this one? 10. Now again see the line of action of this force passes through this one. So this force you have to neglect. Now next one, RB with us. The tendency of this force to turn about this point in anti-clockwise direction. For anti-clockwise with the minus sign. So what's about the distance? 4 plus 2 plus 4 plus this one 2 meter. So how much? 1 4 plus 4 8 8 and this one 3 equals to 12. Okay. So solve this to get the value for the RB. Therefore RB equals to, we will solve this one better. Yes. So if I take this RB towards one side, okay, RB multiplied by 12 term will come here and this term will remain towards the other side as it is. Here RB turns about this point in anti-clockwise direction. For that you need to do a positive sign for the same. Okay. If I just keep this term towards the one side and if this terms to the other side, automatically this term becomes a positive. Here we can get the 10 multiplied by 4 plus 50 plus sin 30 multiplied by 6 plus 20 multiplied by sin 5 multiplied by this 10 and term divided by 12, because here RB multiplied by 12 with us, 12 goes in denominator. What's about this one? 10 multiplied by 4 plus 50 multiplied by 30 divided by 6 plus with us 20 multiplied by 5 divided by 10 with us equals to divided by 12. So here we can get the RB equals to 18.868 kilonewton. Once we get the value for the RB, substitute this value of RB in equation number 2. Here is some today equation 2. What we get here? A equals to 31.42868. Calculation 1. So we can get that 12.77 at the answer. Therefore 12.77 this we can get the value for. Okay. Once we get the value for the VA, You can easily get the value for RA. For that, here RA equals to top HA square plus A square. This relation get the value for RA. RA equals to, for that HA with us 27.13 5 square of this plus 12.77 square of this. To solve this, get the value of RA. Square root of 12 point, square root of 23 to 5 square of this term plus A with us 12.77 square of this. Get the 29.98 9.8. So once we get the value for RA, just get the value of angle theta. No doubt the value for the HA, sorry, this one RB and RA with us. But if you just look towards this diagram, RB vertically in the upward direction. For the value for this one with us. After solving this, we can get the value of RA. But what's about the angle made by that RA with the horizontal line? For that, you need to do one more step here. For that, let's see HA value with us and RA value, VA value with us. So get the inclination made by that RA. Now, inclination by RA is we get to the equation tan of alpha or tan of theta equals to, so A with us and HA with us. We have seen case of that method of resolution to get this one. But the expert step for the same. So VA with us, A is there 12.776, HA with us 37 to 5. Solve this and get the value for alpha. Alpha is nothing but the tan inverse of 12.776 7.85. So alpha equals to 12.77 by 5. All this we can get the alpha equals to 25.21 degree. And last you can just show your answer. Here I value with us 8 kilonewton. Next time well 5 to 1 RB with us 868 answer. So next problem, for the beam shown in figure, find the reactions. So beam is given in this way. So as per our previous discussion, first of all you have to draw the free body diagram of the given system. Just mention free body diagram. I'll just draw this free body diagram here so that you can adjust your entire problem. Here, the free body diagram of one beam. So that you just here, what is the beam in front of you? First of all, just show that beam. Okay. So what's about the next one? The support was both the end. Here with us, hinge support. In case of hinge support, the two reactions will come. One will come in horizontal direction. So there is nothing but the HA. One will come in. There is nothing but the A. What's about the next one? the distance of 5 kilometers with the point load of 1 meter to the spot. So the point load first, okay, that we can just the remaining code, your reactive carefully, or just we can just show the same. Here the A point plus and B point is here. Here point. In case of roller support, the two reaction here RB. Now here point load with us. Apart from this one, what's about this one? Couple 10 kilonewton. This one kilonewton meter. You just see here this portion, the uniformly distributed load with us and uniformly varying load with us here. Now our aim is to convert this uniformly varying load into point load. So how you can convert that? Already we have seen in the case of theory. This actually a point load, sorry, varying load with us. Just convert that uniformly varying load point load. What's about the length for this span? I consider this length. One here 2 meter. For this 2 meter length, to convert this one uniformly varying load into point load. Okay. So for that, what's about the length for this one? Then one in the problem is 2 meter. So what's about the area for this triangle? For that, uniformly intensity of the uniformly varying load with us 2 kilonewton per meter. So what's about the location of the point load? What's about the magnitude of the point load? Point load here is the thing, but here in short, the area of this triangle. What's about the area for the triangle? 1/2 base length with us 2 meter, intensity of the load with us 2 kilonewton per meter. Okay? So this is nothing but the point load. Here is the location of that point load at a distance of L by 3 from the front end. Okay, already we have seen that part. Distance must be L by 3. L by 3. L by 3 means here. What's about the length given here? 2 meter. L by 3 means here 2 by 3. Okay. So what's about this distance? From this side L by 3 and from this side 2 by 3 into L. 2 by 3 into L means here length with us 2 meter. Entire length with us 2 meter. 2/3 of 2 and here 1/3 of 2 in short. Okay. In this we can get that distance. And in this way, we can get the point load. Okay, so I'll just show that point load at a distance of 1 by 3 L by 3 from this end. Means L by 3 means here 2 by 3 from this side 2/3 of L. 2/3 of L means 2/3 of 2. What's about the point load? Made of this point load 1/2 base with us 2 and height with us 2. So you can get that point load. So next one already was shown here 2 kilonewton. Next one 10 kilonewton meter with us. Now what's about this one? How to convert this one point load? Point load, sorry, this one uniformly distributed load into uniformly distributed load into point load. See the length for this portion of the beam. This one with us 1 meter. What's about the intensity of the load? Intensity of the load with us 1 kilonewton per meter. This is actually intensity or the value of the load with us. Now my aim is to convert this 1 kilonewton per meter load, this one, into point load. So point load that can be converted into point load in this way. So what's about the magnitude for the same? Value or intensity of the load multiplied by distance. So distance is here 1. And what's about the intensity of the load or magnitude of the load with us? 1 kilonewton. So 1 multiplied by 1, that will located at a distance of half from both sides. L by 2 from this side and L by 2 from this side. So L by 2 means here 1 by 2. So total length with us 1. So half of that 1 is nothing but the here half and here half will come. I'll just show that load here. Okay. 1 multiplied by 1. What's about the distance? Distance must be half means here 0.5. 0.55. Okay, so apart from this one, the rest of the distance is shown here. 1 meter. Here is the 1 meter with us. Here the 2 meter. Once this diagram is worked, now just concentrate on the conditions of equilibrium. Now apply the conditions of equilibrium. Applying conditions of equilibrium we get. Now this is the case of general force system. In case of general force system, the three conditions with us: the summation of f of x equal to 0, f of y equals to 0, and the moment about any point equals to 0. Just apply these conditions one by one. First one with us summation of all the forces along the horizontal direction equals to. Now focus only on the horizontal forces. All the forces right now with us, okay, either in vertical upward direction or this one in upward direction or downward direction. What's about this one? No any force with us in horizontal direction. So what's about this one? HA becomes 0. For the value for the HA with us 0. Now what's about next one? The next condition of f of y equals to 0 equals to. Now focus only on the vertical forces. So here is the vertical force. First vertical force with us, whose magnitude VA with us. Okay. So VA. What's about this one? Plus vertically in the downward direction to the minus sign here. What's about the magnitude for this one? 2 get cancelled, only 2 will remain. What's about this one? Vertically in the downward direction, again to the minus sign for this one. So what's about this one? Now in this case, don't consider this load. While taking the moment, in that equation you need to consider this one. Okay, so in this case you have to consider only the forces along vertically downward direction or upward direction. What's about this one? 1 multiplied by 1 is nothing but the 1 vertically in the downward direction. Okay, so what's about this one? RB vertically in the upward direction. Solve this or just get the first relation, first equation. So here VA plus RB equals to how much? This one. So in this we can get the 5 plus 2, 7 plus 1, 8. 8 kilonewton again for this A plus RB. Give equation number 1 for this. Now just take the moment. Use this equation about point A. Taking moment about point A. Just summation equals to 0 for the equilibrium. Just continue. So if you just say the first one, HA, line of action of this HA passes through this one. Just consider that as 0. The next one, line of action of this force passes through the same point. Get the moment of this point about this point from 0. The next one is here. This force is nothing but the 2 kilonewton. 2 kilonewton. You have to take the moment of this 2 kilonewton about this point. So here is the point and here is the force. See the line of action of this force. For a particular distance with us, 2/3 of 2. Just mention here 2. The tendency of this force to turn about this point in clockwise direction. To the minus sign for this one. Multiply by 2/3 of 2. Just mention as it is. Now next force is here 5 kilonewton. 5 kilonewton also turns about this point in clockwise direction. Give the sign for this one. Multiply by distance 2 meter plus 1, 3 meter distance with us. Now you have to consider this one couple. So this turns about this point in clockwise direction. For clockwise, give the minus sign. What's about the next one? 1 multiplied by 1 is the 1 kilonewton. You have to take the moment of this force about this point. Now see the distance. Up to here we can get the 2 meter plus 1 meter, 3 meter, 4 meter. This force, the distance of 0.5 with respect to this one, and this distance is equal to 1 meter. That is here. Air length with us 2 meter, half of this one 1 meter. So here 0.5 with us means the total distance 2 plus 1, 3, 4, 5, and what's about this one? 0.5. Hence here you can get after this 10 kilonewton force, 10 kilonewton meter, this is the 1 kilonewton force with us, Also, this force turns about this point in the same direction, in clockwise direction. Give the minus sign here. So 1 multiplied by distance with us 2 plus 1 plus 1 plus 1 plus this 0.5 means here 5.5. What's about this RB? RB turns about this point in anti-clockwise direction. See the distance of this RB with respect to this one, 4 plus 1 plus 1 plus 2. So how much? Get the 6. If you look towards this equation, only single unknown is here. So solving this equation, what we get? Solving, we get RB equals to if I take this RB, the terms towards the other side, then all the terms become positive. 2 multiplied by divided by divided by together just divided by divided by 2 5 multiplied by 3 divided by 3. The sign should be given because all the terms it goes to the other side. Plus sign plus the next one 10 plus 5.5 multiplied by 1 equals to 6 equals to beta RB equals to 5.527 kilonewton. Once we get the value for the RB, substitute this in equation number 1. Substituting RB equation 1. So we get here, therefore we get A equals to, I substitute this equation number 1, so 8 minus this RB, but we can get the VA. A equals to 2.47. A equals to 2.47. So as the value for this one, HA is 0. Straightforward as HA equals to 0. A must equals to RA. Just mention here answer. RA equals to equals to 2.47 kilonewton. RB equals to 5.527 kilonewton. I hope this problem cleared you. Thank you.